Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Understanding software requirements is a key part of installing, supporting, and troubleshooting applications on any system. Each application has specific needs for hardware, operating system, and supporting frameworks. If those requirements are not met, the software may fail to install, crash during use, or perform so poorly that it becomes unusable. Technicians must be able to match system specifications to application requirements before installation begins. The A+ Core 2 exam includes questions that test this knowledge in scenario form, where you must identify what's missing or what needs to be adjusted. Most applications provide system requirements in two categories: minimum and recommended. The minimum requirements describe the lowest acceptable configuration that allows the application to launch. This includes the smallest amount of memory, the slowest acceptable processor, and the lowest supported operating system version. Recommended requirements provide a smoother experience and include faster processors, more memory, a solid-state drive, and a modern operating system. Meeting only the minimum specs may lead to slow response times or limited functionality, while meeting the recommended specs ensures full compatibility and stability. Checking hardware compatibility is essential before installing software. In Windows, you can use tools like System Information, Device Manager, or the Performance tab in Task Manager to review current specs. Third-party tools like CPU-Z or Speccy may offer additional detail. When reviewing an application's documentation, compare the listed requirements to the hardware available. Pay close attention to architecture. Some applications require a 64-bit operating system and will not run on 32-bit systems. This mismatch is a frequent cause of failed installations and support tickets. Operating system version and edition compatibility must also be considered. Some applications are not supported on older versions of Windows or may require specific editions such as Pro or Enterprise. For example, an application might require features that are only available in the Pro edition of Windows. macOS and Linux also have version-based restrictions. Some software only runs on specific kernel builds or desktop environments. If a mismatch exists, Windows offers a feature called Compatibility Mode that allows older applications to run in an emulated environment. This is useful when software is no longer being updated. In addition to hardware and operating system compatibility, many applications depend on supporting frameworks or components. These are known as dependencies. Examples include the .NET framework, Java, or Visual C++ redistributables. If these components are not installed, the application may fail to launch or crash immediately. Some installers check for these dependencies and prompt you to download them, while others install them automatically. If you see a missing DLL error or runtime warning, it often indicates that a required dependency is absent or outdated. Storage and disk space must also be evaluated before installation. The listed install size is usually the compressed size of the application files. During installation, temporary files are created that require additional space. Applications also generate logs, cache data, and updates that take up more room over time. Using a solid-state drive improves load times, especially for larger applications. Technicians should ensure that at least double the listed install size is available, especially when planning deployments or installing productivity suites that expand over time. Some software includes display or screen resolution requirements that affect usability. For example, if the application's interface is designed for a minimum resolution of 1280 by 720, running it on a lower resolution display may cause windows to be cut off or buttons to disappear. Other applications may require graphics acceleration or a dedicated graphics processor. This is especially true for video editing, photo manipulation, or three-dimensional rendering software. Verifying graphics requirements is essential when supporting creative professionals or performance-heavy environments. Licensing and activation are another layer of compatibility. Some software requires a product key at installation. Others require a user to log in with a subscription-based account. Cloud-activated tools may tie the license to the hardware or use account-based validation. If the license is invalid, expired, or tied to another device, some features may be locked, or the software may deactivate itself. Understanding the type of licensing model, whether it's perpetual, subscription, or volume, is necessary when troubleshooting installation failures and feature limitations. Many applications require administrative permissions to install or update. This means the user must either be signed in with an administrator account or approve the operation through User Account Control, also known as UAC. In enterprise environments, the technician may need domain administrator rights or a special installer account. If these permissions are not available, the installation may appear to succeed but fail silently, or the application may lack the necessary access to run correctly. Always verify privileges before installing on systems with strict user controls. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Backward compatibility is an important concept, especially in environments that rely on legacy applications. Some older software only runs on outdated operating system versions or depends on now deprecated system components. When this happens, technicians can attempt to use compatibility mode, which emulates the behavior of a previous Windows version. This is configured by right-clicking the application shortcut, selecting Properties, and enabling compatibility settings under the Compatibility tab. In some cases, virtualization may be required. Running the application inside a virtual machine with the correct operating system can preserve functionality without compromising the host. Application virtualization offers another solution for compatibility challenges. This technology runs software in a sandboxed or isolated environment. Examples include Microsoft App V, Citrix Application Delivery, and portable application platforms. These tools allow incompatible or legacy applications to run on modern systems without modifying the base operating system. Virtualization protects the host system from compatibility-related conflicts and improves manageability. In enterprise deployments, virtualization is often used to deliver standard applications across different user roles and hardware profiles. Let's consider a real-world example. A user installs a legacy accounting program on a modern system running Windows 11. After launching the app, it crashes immediately with a generic error. The technician checks the vendor documentation and discovers the app was built for Windows 7. By enabling compatibility mode for Windows 7 and granting administrator permissions, the app launches successfully. This scenario shows how understanding application compatibility settings can resolve issues without replacing the software. Most modern installers generate log files during the installation process. These logs are typically saved in the %temp% directory or within a designated program folder. When an installation fails, reviewing the log file can provide error codes, missing dependency warnings, or access denial entries. These logs are especially useful when the error message shown to the user is vague or generic. Installation logs are valuable when contacting vendors or escalating issues to higher support tiers, as they provide detailed technical evidence of the failure. Before deploying applications across many systems, technicians often perform pilot testing. This involves installing and using the software on a small set of representative devices. If any issues appear, such as slow performance, incompatibility, or user confusion, they can be addressed before broader rollout. Virtual test environments are also used to simulate various hardware and software combinations. Testing prevents large-scale disruption and helps confirm that the application meets the technical and usability needs of the organization. Pilot testing is a core practice in change management and deployment planning. Enterprise compatibility planning goes beyond technical testing. It includes documentation, formal change control procedures, rollback planning, and scheduling. Organizations may use imaging tools to preload applications onto systems, and they often standardize software sets based on user roles. Compatibility assessments are part of upgrade cycles, new software evaluations, and vendor transitions. Policies like application whitelisting restrict what can be installed, improving security and reducing help desk requests. Understanding this planning process is helpful when working in managed IT environments. Mobile applications also require compatibility checks. Each app may have minimum supported versions for iOS or Android, along with hardware requirements like memory, processor speed, or display resolution. Some apps will not install if the device is jailbroken, rooted, or lacking a necessary hardware component. App Store listings often specify supported devices, operating system versions, and feature availability. Technicians supporting mobile users must know how to interpret these listings and troubleshoot based on App Store error messages or blocked installations. When a compatibility error occurs, the technician's first steps should include verifying the operating system version, available memory, and required frameworks, updating the system, installing a missing dependency, or enabling compatibility mode may resolve the issue. If the problem persists, using an alternate software version or contacting the vendor for guidance may be necessary. Each action should be documented, especially in enterprise support settings, where tracking issues helps identify trends or plan future upgrades. The A+ exam includes several common question types related to software compatibility. You may be asked to match system requirements to a hardware profile, identify a missing component based on an error message, or choose the appropriate fix for a failed installation. Other questions may ask you to determine which version of Windows is required to run a specific application or when to use virtualization. Reviewing real application documentation and testing software on different setups is an excellent way to prepare for these items. To summarize, verifying application requirements and ensuring compatibility is a core part of software deployment and support. Technicians must evaluate hardware specs, operating system versions, supporting frameworks, and licensing requirements before installation. Tools like compatibility mode, virtualization, and log files help resolve many issues without escalating to development or vendor support. These skills are tested on the certification exam and applied daily in IT environments. Ensuring that applications run correctly improves productivity, reduces frustration, and supports business continuity. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.